everyone and welcome to new discussion on mosaicing, subset, some sampling techniques and their applications under this remote sensing essentials course. Sometimes we face problems about mosaicing because your area of interest might be covered by 2-3 scenes, maybe 4, or sometimes a large area has to be covered, and for that scenes have to be mosaicked. So, or a collage we also say. So, that has to be made, and the purpose here is to create a mosaic which does not have the seams, or create a seamless mosaic. And generally it is quite difficult, but still there are techniques which are available in digital image processing and also in softwares by which we can make mosaic of several scenes and data sets into one single image. So, if we look the definition, that basically it refers to the process of combining spatially overlapping images into a single data set to produce a spatially continuous image based on an aggregation function. Now, this spatially continuous image means here also that we need not to have a seam as far as possible, but sometimes two adjacent scenes may have different dates, generally they are, and if time gap is big between these two adjacent scenes, then it becomes very difficult to remove the seam or the changes which are present in two different images. But nonetheless, also merging sometimes word is also used, but merging or making mosaicing is bringing two adjacent scenes like in this figure which is shown here, that two adjacent scenes are here, and then output is created, but the output currently is having a seam, whereas seam should not have been there, but anyway that seam can also be removed by certain techniques, certain way, and a appended or a combined mosaic can be created. When we see the real images, then we this is the mosaic which we can do in a commercial software, which I have been discussing in demonstrations also. Two examples of mosaicing two scenes, band, two simple band not colored one are shown here, but color composites can also be mosaicked like this. So, the common area which you are seeing is this one, the common area. Now, here during mosaicing it has to be declared that what should be done with the common area, whether an average should be taken or whoever is having whichever you decide by or decided by the user, like in this one the one which is in the bottom can have the the pixel values in that area which is the overlapping part, and for example on the right side this is what we are seeing, a mosaic. And if we do not see the edges of this image, then probably in this particular example the seam between two scenes cannot be identified. So, this is an example of a good mosaic, but these are basically the example is not exactly from satellite images, but from aerial photographs one, and even if they would have been satellite images, but if they are one after another, that is a path in the same path, that means they are representing the area of the same date, then creating mosaic is not difficult or especially seamless mosaic. But when two different orbits images are there and time difference is there, then making a seamless mosaic becomes little difficult. But there are ways to minimize that seam, and we can have such example. Like here again, and this is from the same commercial software, and various images have been taken here, and a seamless mosaic is what you see on the right side. So, lot of scenes are here, but their seams have been minimized, except that where the margins are there or edges of one scene with another is there, then it becomes very difficult to remove that one. Otherwise, it is possible to create a seamless mosaic. The example which earlier we have taken about this the seam, and a seam can it is not necessary that a seam should always be a straight line. Seam can also be an arbitrary line like here, and then mosaic can also be created. Here is the perhaps the best example here of taking or creating mosaic of two adjacent scenes which are having different spectral characteristics. That means because they belong to two different dates. Now, how it can be done? So, the technique here is the matching the histogram, and that is why when we started discussing digital image processing of satellite data, we started with the histogram. The histogram becomes very important in almost all processing of remote sensing data. So, here the histograms of all these three scenes which are having different characteristics, spectral characteristics, have been combined by histogram matching technique, and then you do not see any seam in between. Like here you do not see any seam here, seam is completely gone. So, in that way this mosaic can be created. Here the example of 3, but there may be even 30 scenes. The only thing, the output image would be of a very large size in terms of computer memory. So, one has to take care about that part as we are moving towards higher and higher spatial resolution, and therefore, our the data requirements or the data handling requirements is becoming very big, and therefore, one has to take care about the size. Otherwise, it is possible to create a seamless mosaic of various scenes. One more example here is, rather than matching histogram, here is the example of color balancing by excluding areas. That means the common areas have been excluded, and what we find that of course a mosaic has been created again using the same commercial software, but sometimes on the edges you are seeing it is showing some darkness. So, probably that part becomes difficult to remove. Nonetheless, it is always tried to achieve the best possible output through different mosaicing techniques. Now, this is the example from Tibetan Plateau, and these are the of Landsat 8 data having 78 scenes, and what we are seeing, if you do not see the edges, the boundary, then in between probably it is very difficult to find a seam because it has been created in such a manner that the seam does not become obvious. Nonetheless, at some places, because of the time difference between different images, you see here the seams are also visible. Otherwise, it is a quite good product. So, whether it is a 2 scenes, 10 scenes or 30 scenes, or in this example 78 scenes, mosaics can be created as far as possible, the best seamless mosaic. However, see, this is a Landsat 8 and there are 3 bands, it would be a many gigabyte mosaic would be there. So one has to handle that much of the data. Otherwise, technically it is possible to create seam of hundreds of scenes together. One of the best example of seamless mosaic and the orthorectified image which is available for the globe, and it is like in this one there are 24 images of between 1984 to 1997 of central India around Nagpur has been mosaiced. So see the time difference. It is more than about 13 years time difference is there. Nonetheless, this is a completely seamless mosaic of 24 scenes, and nowhere you see any seam between these images, which are the 24 images. So it is possible to create seamless mosaic, and one can cover his area of interest through such products. Now, one of the best examples of seamless mosaic of entire globe which we see through Google Earth, as you can see here also, though once you start zooming it, then what happens that individual scenes start appearing, and of course there are seams also. But at this scale or even further at zoom scale, to an extent we do not see a seam at all. But when individual scenes boundaries start appearing, then because of the time difference between two adjacent scenes, if it is large or the season difference is there, then definitely we observe the seams even in the Google Earth. There might be time difference, there might be difference in the spatial resolution as well, and that is why the seams are available and seams are seen. Otherwise, we can have a completely seamless data, and this is one of the examples of at a global scale. Now, another important step which we have to take many times with the satellite data or in digital image processing is to create a subset of an image. That means extracting our own area of interest. In this example, that the image which we have been seeing of Nagpur area, which is Landsat TM and ETM 24 scenes, the same image is here, but this part of that image has been extracted, a subset has been created, and this is what you are seeing here on the right side. So, because my area of interest may fall within this one, within this red box or a rectangle, and I need not to have in my hard disk or in database the entire mosaic, which is obviously a very large data set. So, then it is possible to either create a subset or extract the data or the subscene from a big mosaic or big scene also. So, many times we need to do such steps to first of all to reduce the unnecessary processing during the digital image processing. And though this somewhere in the backup system we may keep this scene the full mosaic, but for further processing along with other data sets we may create a subset, and creating subset is not difficult at all. In this example, subset has been created using a rectangle, but an arbitrary line like a subset of a watershed, subset of a political boundary, district level or state level can also be created without much problem. So, only thing you require a polygon boundary, like here one polygon boundary has been chosen, that is a rectangle, red rectangle is shown, and one can have some other boundaries, but it has to be a polygon, and then extraction is possible. Creating a subset of an image is easily possible. Now the third topic of this discussion is about image subsampling. It is not possible, reverse is not possible. What I mean here is that if I am having coarse resolution remote sensing data, once it has been acquired say at 80 meter resolution, then it is not possible by any computer techniques or based on AI or other techniques to create an image at say 10 meter resolution. But the reverse is possible. Reverse means subsampling can be done, and we can create a image at a image which has been acquired by a sensor at 10 meter spatial resolution can be subset or can be subsampled to 80 meter resolution as shown here. So, basically the idea of subsampling of image subsampling is to basically reduce the number of pixels from an image, that is throw away every other row and column to create a reduced size image. Sometimes in some applications, because when we are using multiple data sets, all data sets may not have the same spatial resolution. So, we may decide that some data set which is having a high spatial resolution should be reduced to that particular resolution. Say we decide 80 meter resolution. So, a 10 meter input image has to be reduced to 80 meter. But the reverse, as I have said, 80 meter resolution image cannot be improved to 10 meter resolution. So, subsampling is definitely possible, and this is done sometimes in some special circumstances, and such steps are taken in digital image processing to reduce. So, the reduction is by reducing the number of pixels both in both directions, that is in row and column, and creating a subsampled image. As example here, that we can using a 10 meter spatial resolution image, first it may be reduced to 30 meter resolution and then 10 meter. This is let me remind you, this is not data compression. Data compression is different thing. Though when we reduce the spatial resolution of this image, like in this example, definitely there will be less space requirement for 80 meter resolution as compared to 10 meter. Maybe just 1/8 of the original image. So, suppose the original image was of 8 megabyte, then this 80 meter resolution image may require only 1 megabyte of image. However, this is not at all a compression technique. Compression techniques are different, and we will have a completely separated treatment and discussion over compression techniques of satellite images. But here it is subsampling. So, this brings to the end of this brief discussion about three things. One is about mosaicing of images, many images, multiple images starting from 2 to 200. It is possible, and also creating a subset of an image, and also finally we discuss about subsampling. These are mosaicing is a very common technique in digital image processing. As I have already mentioned that because of several times our area of interest may fall in 2, 3, 10, 15 scenes. It depends on what resolution images you are using and what kind of how big your area of interest is. So, one has to be very careful while making mosaics. Sometimes also we are having already mosaics available, we want to create a subset, a small area, because my area of interest may be smaller, then those techniques are also available. So, subset is basically you can call as a reverse technique of mosaicing. And lastly, we have discussed about the subsampling technique. There is another word which is used in digital image processing, which we discussed during georeferencing, which is called resampling. So one should not get confused with resampling. Resampling is done to find out the new pixel value in a target grid. That is the last step of georeferencing. But subsampling is completely different. So one should not get confused about these words. So subsampling is different, resampling is different. So this brings to the end of this discussion. Thank you very much.